Let's look at how to use matrix to solve systems of equations. So we are going to use an array of real numbers, which is called a matrix. The plural of matrix is matrices. So a matrix looks like this. So this just has one entry. This one has multiple entries. 1, 2, 3, 4 entries. This one has 4 entries. This one has 6 entries. And the way we name these is by how many rows and columns. So this would be one row, one column. So this would be a 1 by 1. This would be a 1 row. See how there's just 1 row, but we have 4 columns. So this is a row by column, so 1 by 4. So M represents your rows, N represents your columns. So that's the dimension. So this is a 2 row by 2 columns. This is a 2 by 2. This one is a 1, 2, 3 row by 1, 2, 2 column. This is a 1, 2, 3 row by 1 column. And you can also note what an entry is. So let's say we want to do IJ. So let's say 1, 2. So on row 1, column 2. So let's say this one, row 1. So this is row 1, column 2. So this would be our A entry 1, 2. Okay. So we are going to look at the augmented matrix from a system. So what we're going to do is we're going to use all of the coefficients and then our constant to write our matrix. So on here we have the system of equations, and we are going to write this in matrix form. So how I'm going to write this is 2, 1, 5, 3, negative 2, and 4. So make sure that these are like your x's are in a column, your y's are in column, and then this is your constant. See how it says equals. So we can do this little thing like that, or we can leave it off. But these represent the x coefficients. These represent your y coefficients. And this is a 2 row by 3 columns. So it's a 2 by 3. Okay, example 2. See how we have y's here, z's here, but there's only one x, a 9x here. So I'm going to put a 0x in that position. So now it's in the correct form. 9, 2, negative 3, 20, 0, negative 25, 11, and negative 5. And this is a 2 row by 4 column, a 2 by 4. Okay, so we are going to do some operations to systems. But we need to know how to go from a matrix to a system. So we're going to say this is x, this is y, and these are our constants. So this is 3x plus 4y equals 0. And this would be 1x, or just x, minus 1y, so minus y equals 7. So this is my system of equations that matches the augmented matrix. Okay, when we have this, we can do x, y, and z. So we would say 12y plus 3z equals 0. Negative 2x plus 18y plus 0z equals 10. And then x plus 7y minus 8z equals 43. So these are equations. So we're going to do some row operations in order to what's called reduce the matrix. What our goal is going to be, which you'll see a lot more in the next unit or the next section, is we want not necessarily a 0 there. We want these, so let's say it's a 3 by 4, we want it to look like this. Okay. And then the last column can be anything you want. Those can be anything. But the goal is for you to have a diagonal of ones and then 0 in the corner like this. So this is called row reduced echelon form. Okay. Or it could just be reduced echelon form. Okay, so things that you can do, you can interchange rows. You could be like, okay, row 1 and row 2 are going to switch. You could multiply one of the rows by a non-zero constant. So let's say you want to multiply it times half or times 2 in order to get 1 in the diagonals. You could add a multiple of one row to another. So you could do like -2 times row 1, add it to row 2 to get your new row 2. So I'm going to show you what that looks like. Okay, so fill in the blank using elementary row operation to form a row equivalent matrix. Okay, so see how row 1, so this is your row 1, this is your row 2. Row 1 is the same as row 1, so we didn't do anything there. But row 2, something happened to it to make the first spot right here equal to 0. So we've got to figure out how to do that. So it's a lot like elimination. What we want to do is we want to get rid of the x value. So the way we do that is we're going to multiply row 1 times -3 and then add it, because -3 plus 3 gives me 0. So I'm going to write it over here. So I'm going to multiply -3 times row 1. I'm going to add it to row 2 to give me my new row 2. Okay, so I'm going to go ahead and write -3 times row 1. So -3, -6, -9. And then I'm going to go ahead and add my row 2. So my original row 2 is 3, 12, 5. I'm going to add those up. And I get 0, 6, -4. And see what we have here? Just a 6. All right. So all we did was this was our row operation. Okay, let's look at the next one. Okay, so row 1, it looks like it went from -4 to 1 right here. But row 2 is the exact same. So what am I going to have to multiply -4 by to get a 1? I'm going to have to do it times a -1/4. So -1/4 times row 1 is going to give me my new row 1. So times -1/4 gives me a 1. Times -1/4 gives me a -2. Times -1/4 gives me a 5. So that was the operation that we did. Okay, let's go to the next one. Row 1 is the same, row 2 is the same, it's row 3. So we want to use row 1 to help us, because I can multiply row 1 times 5 and then add those together. 5 times row 1 plus row 3 to give me my new row 3. So I'm going to write it over here. So -5, I'm going to multiply this all times -5. So that gives me, oh, times +5. Sorry, it's a positive. Let me erase that. So that'd be -5, -10, 15, -10. I'm going to add it to row 3. So 5, 4, -7, 6. I get 0, -6, 8, 4, which is this. So this was a row operation that was done. So you use any of the ones to your advantage, because you can multiply them times anything you want, And so you always want to do the opposite of that one so you can get rid of it and make that a 0. Okay, let's look at this one. All right, so I want to make this a 0. So I'm going to have to multiply this times the opposite, so -2. So this is going to be -2 times row, because see how these are the exact same, and we get a 0 here. So -2 times row 1 plus row 2 to give me my new row 2. So that's going to be -2, -8, -6, 2, 10, 5, 0, 2, and -1. So that is a 2. If I want to go a step further and get a 1 there, I could just do times 1/2. And then that would make that 2 into a 1 and also change the -1. Okay, so it says fill in the blank. Okay, that's row equivalent matrix. Okay, let's look at this one. All right, it looks like row 1 is the same. It's row 2 that's different. So I'm going to use that row 1 to my advantage. I'm going to multiply this times a -3. So I'm going to write it here. -3 times row 1 plus the row 2 to give me my new row 2. So -3, -3, -12, 3. Go ahead and write my row 2. Add those together. Okay, so go ahead and fill in the blanks here. Okay, I gotta do the next one. So I need to do the opposite of this. So I'm gonna do 2 times row 1. 2 times row 1 plus row 3 to give me my new row 3. So that would be 2, 2, 8, -2, -2, 1, 12, 6. So I multiplied row 1 by 2, and then I'm adding it to the row 3. I get 0, 3, 20, and 4. So go ahead and fill in the blank here. Okay, so that's how to go from there to there. From this one over here, we did these 2 operations to change row 2 and row 3. Okay, so let's look at the next one. We want to change, so row 1 is good. We want to change row 2. So how do we change from a 5 to a 1? We can multiply it times any number. So I would multiply it times its reciprocal. So I'd do 1/5 times row 2 to give me my new row 2. So 1/5, so 0 is still going to be 0. 1/5 times 5 is 1. 1/5 times -2 is -2/5. 1/5 times, oh, this should have been 6. I bet somebody caught that, didn't he? It should have been 6. I don't know why I did that. So it should be 6 right here. Okay, so 1/5 times 6 to give me 6/5. So it's okay to have fractions because we can deal with those later. Okay, and then didn't look like they did anything to row 3. Okay, so that is it on that operation. So we will finish this in class.